morning class. So, our topic for today is all about truth table of inference. So, class, before we proceed to our lesson, let's know first about the objectives of this lesson. So, objectives. At the end of the discussion, the student would be able to determine what is truth table for inference, identify the different rules of truth table for inference, know the different use of truth table for inference. So, let's begin to our topic. So, an argument in propositional logic is a sequence of propositions. All but the final proposition are called premises. The last statement is the conclusion. And the argument is valid if the premises imply the conclusion. An argument form is an argument that is valid no matter what propositions are substituted into its propositional variables. If the premises are P sub 1, P sub 2, P sub n, and the conclusion is Q, then P sub 1 and P sub 2 and P sub n, premise Q is the tautology. So, the inference rules are all arguments, simple argument form that will be used to construct more complex argument in the forms. So let's proceed to our topic. So let's proceed to the first rule of inference. So addition, corresponding tautology. P implies P or Q. So P, therefore P or Q. So in P, so we have two variables. So 2 squared equals to 4 divided by 2 equals to 2. So in P, so there is 2 true and 2 false. So in Q, 2 divided by 2 equals to 1. So true, false, true, false. So P or Q, so true, true, so true. True, false, true. False, true, true. False, false, false. So P implies P or Q, so true, true, true. True, true, true. False, true, true. So false, false, false. So this truth table represents the first rule of inference, which is the addition. So let's proceed to the next rule of inference. So the next rule is the simplification. So corresponding tautology, P and Q implies P. So P and Q, therefore P. So in P, so in the previous discussion, so we have two variables. So 2 squared equals to 4. So 4 divided by 2 equals to 2. So we can see in the row of P is there is 2 true and false. So in Q, 2 divided by 2 equals to 1. So 2 true, false, true, false. So in P and Q, so true, true, true. True, false, false. So false, true, false. And false, false equals to false. So P and Q implies P. So true, true equals to true. True, false equals to true. False, false equals to true. And false, false equals to true. So this truth table represents the second rule of inference, which is the simplification. So, do you have any question, class? So, no. Let's proceed to the third rule of inference. So, the third rules of inference is the conjunction. So, the corresponding tautology P and Q implies P and Q. So P and Q, so therefore P and Q. So we have two variables, so 2 squared equals to 4, then 4 divided by 2 equals to 2. So in P, we have 2 true and 2 false. So in Q, 2 divided by 2 equals to 1, then TF, and P and Q, T, TF, F, T. So in P and Q implies P and Q. So true, false. So true, false, true. So false, true, true. So false, true. So this truth table represents the third rule of inference, which is the conjunction. So let's proceed to the fourth one. So the fourth rules of inference is the modus ponens. So corresponding tautology P, and if P then Q implies Q. So P and if P then Q, so therefore Q. So we have two variables. So 2 squared equals to 4 divided by 2 equals to 2. So in P, we can see that there is 2 true and false. So in Q, 2 divided by 2 equals to 1. So TF. So true, false, true, false, true. So P and if P then Q. So true, false, false. So the next one, P and if P then Q implies Q. So true. So this truth table represents the fourth rules of inference, which is the modus ponens. The fifth rule of inference is the modus ponens. So corresponding tautology not Q, and if P then Q implies not P. So not Q, if P then Q. So therefore not P. So we have two variables. So 2 squared equals to 4 divided by 2 equals to 2. So in P, we have 2 true and 2 false. In Q, so 2 divided by 2 equals to 1. So TF. So not Q. So this is the negation of Q. So FT. So if P then Q. So true, false, true. So not Q, and if P then Q. So T. Then not P, this is the negation of P. So false, true. So not Q, and if P then Q implies not P. So true. So these truth tables represents the modus tollens. So let's proceed to the next. Disjunctive syllogism. So the corresponding tautology P or Q and not P implies Q. Then P or Q, so not P, so therefore Q. Q. So, we have two variables. So, 2 squared equals to 4. Divide by 2 equals to 2. So, in P, we have 2 true and 2 false. So, Q, so 2 divided by 2 equals to 1. So, 2 true, false, true, false. So, not P. This is the negation of P. So, false, false, true, true. So, P or Q, so true, true, true. True, false, true. False, true, true. So, false, false, false. So, the P or Q and not P. So, true, false, false. So, true, false, false. True, true, true. So, false, true, false. So, the P or Q and not P implies, so, true, 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 true. So, this truth table represents the one of the rules for inference, the disjunctive syllogism. So, let's proceed to the next rule of inference. Hypothetical syllogism. So, this corresponding tautology, FP then Q and FQ then R implies FP then R. So, FP then Q, so FQ then R, so therefore FP then R. So, in this truth table, we have three variables. So, 2 raised to the power of 3 or 2 cube. So, 2 times 2, 4 times 2 equals to 8. So, 8 divided by 2 equals to 4. So, in P, we can see that there is 4 true and 4 false. So, in Q, so 4 divided by 2 equals to 2. So, true, true, false, false, true, true, false, false. And R is 2 divided by 2 equals to 1. So, true, false, true, false, true, false, true, false. So, if P then Q, so true, 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 false, false, true, false, 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 true, true, false, true, true, true. So, false, false, true. So, false, false, true. If Q, then R. So, T, T, T. T, F, so F. FT is T. FF is T. TT is T. TF is F. FT is true. FF is true. So, if P, then R. So, true, true, true. True, false, false. So, true, true, true. So, true, false, so true. So, false, true, so true. False, false is false. False, true is true. And false, false is true. So FP, then Q. And FQ, then R. So, true, true, so true. True, false, so false. False, true, so false. False, true, so false. True, true is true. True, false is false. True, true is true. And true, true is true. So, FP, then Q, and FQ, then R implies FP, then R. So, true, true, true. So, false, false, true. False, true, so true. False, false is true. True, true is true. False, true is true. And true, true is true. And true, true is true. So, these truth tables or truth table represents the hypothetical syllogism. So, do you have any question, class? So none. So let's proceed to the next rule of inference. This is the constructive dilemma. So the corresponding tautology, if P, then Q, and if R, then S, and if P or R implies FQ or S. So FP then Q, FR then S, if P or R, so therefore FQ or R or S. So in P we have 4 variables, so 2 raised to the power of 4, so 2 times 2 equals to 4, times 2 equals to 8, times 2 equals to 16. So 16 divided by 2 equals to 8. So in the P we have 8 true and 8 false. So this one is the continuation. So we have 8 true and 8 false. So in Q, so in Q, 8 divided by 2 equals to 4. So we have true, 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 false, 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 true, 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 false, 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 false. So in R, so 4 divided by 2 equals to 2. So true, true, false, false, true, true, false, false, true, true, false, false, true, true, false, false. So S, so 2 divided by 2 equals 1. So true, false, 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 true, false. So FP then Q. So true, 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 true. So true, false, false, true, true, false, false, true, false, false. So true, false, 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 true, true, false, true, true, false, true, true, false, true, true. So false, false, true, false, false, true, false, false, true, false, false, true. So if R then S. So true, 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 false, 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 true, true, false, false, true, 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 false, false, then false, true, true. So false, false, true, 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 true. So true, false, 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 true is true, false, false is true, true, true is true, true, false is false, false, true is true, and false, false is true. And P or R, so true, true is true, true, true is true, true, false is true, true, false is true, true, true is true, true, true is true, true, false is true. Then true, false is true, false, true, false, true is true, false, false, true is true, false, false then S. So true is true. True false is false. True is true. True is true. False true is false. False is false. False true is true. Is false. Then so false true is false. True is true. True false is false. True is true. True is true. True is true. True false is false. True is true. True is true. So if P then Q, and if R then S, and FP or R. So true. So true. True false true is false. True is true. True is true. False true is false. False true is false. False true is false. So false true is false. True is true. True false true is false. True false is false. True false is false. True is true. True false true is false. Then true false is false. Then true false is false. So if Q or S, so true is true. True false is true. True is true. False true is true. False is false. Then false true is true. So false is false. So true is true. So true false is true. So true is true. So true false is true. Then false true is true. Then false, then false. So false true equals to true. So false equals to false. So if P then Q, and if R then S, and not P, not Q, or not S, implies not P or not R. So false true. So false then true. So false true then true. True then true. False then true. So false then true. False true 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 then true. True then true. True then true. False true then true. So true then true, and true then true. So these truth tables represent the one of the rules for inference, which is the destructive dilemma. So class, do you have any question? So none. So let's proceed to the next rules for inference. So this is the last rules for inference. So the absorption. So the corresponding tautology FP then Q implies FP, FP, and Q. So FP then Q. Therefore, therefore P, F, P, and Q. So we have two variables. So 2 squared equals to 4. So in P, 4 divided by 2 equals to 2. So that's why we have 2 true and 2 false. So in Q, 2 divided by 2 equals to 1. So true, false, true, false. So FP then Q. So true, true, true. True, false, false. So false, true, true. False, false, true. So P and Q. So true, true, true. So true, false, false. So false, true, false. So false, false, false. So if P, then P and Q. So true, true equals to true. True, false equals to false. False, false equals to true. And false, false equals to true. So FP then Q implies P then P and Q. So true, true, true. So false, false, true. So true, true, true. So true, true, true. So this truth table represents the last rule for inference, which is the absorption. So class, please open your cam so that I can see your faces. So class, thank you for listening on my discussion about the rules of inference. So you may now close your cameras. So thank you class and goodbye.